Have you ever opened up a past paper, looked at a probability question, and just felt like it's a bunch of abstract mathematical formulas floating around? I mean, it is so easy to get completely lost in the fractions and the decimals. But here's the secret to mastering this topic. Probability is actually deeply, wonderfully visual. Today, we are going to transform those confusing mathematical formulas into intuitive, visual frameworks that you can actually use. We'll be looking at how drawing out a problem, literally mapping the outcomes, can make complex decisions remarkably simple, and more importantly, help you secure every single mark on those exam questions. Okay, let's dive into our syllabus for this explainer. First up, we're going to navigate the branches of tree diagrams. Then, we'll see how overlapping circles can solve apparent paradoxes in our Visualizing with Venn diagram section. From there, we will establish the ironclad rules for mutually exclusive events. And finally, we'll tackle the tricky scenarios where categories collide using the combined events rule.
Let's kick things off with Section 1, Navigating Tree Diagrams. We'll look at exactly how we can use these tools for mapping out sequences.
Right, so tree diagrams, they are absolutely perfect for mapping out sequential events. Imagine you're reaching into a bag and picking out colored balls, one right after the other. It's a sequence in time, right? A tree diagram draws a literal branch for every possible path reality could take. But I want you to look closely at the cascading impact of a single choice here. Let's start with selection with replacement. Imagine your bag has 10 balls, 3 are red, 7 are black. You pull a red ball. That's a 3 in 10 chance. Now, if you put it back, the bag completely resets. Your chance of pulling a second red ball remains exactly 3 in 10. You just multiply them across the branches, and you get 9 out of 100. Simple, right? But what about selection without replacement? This is where students drop marks. You pull that first red ball, but this time you keep it in your hand. The entire mathematical universe of that bag has just changed. There are only 9 balls left in total, and only 2 of them are red. Your next fraction absolutely has to drop to 2 over 9. Multiply those together, and your probability shifts to 6 out of 90. See how removing just one single item changes the whole game? Before we continue, subscribe to our YouTube channel, Ace the Exams, at @ACEXams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving on to Section 2, Visualizing with Venn diagrams. Let's see how our whole approach has to shift when we swap from sequential events to simultaneous events. So, tree diagrams are incredible for this happens and then that happens. But what if things are happening all at once? What if people belong to multiple categories at the exact same time? Well, that is where the overlapping circles of Venn diagrams come to the rescue. Using a really simple college survey of 40 students, we can instantly visualize that probability is just a fraction of a whole. Look at these numbers with me. 15 chose English, 12 chose mathematics, 8 chose science, and 5 chose art. If we want to find the probability of picking a science fan at random, we don't need complicated algebra here. We just look at the whole, the denominator, which is our 40 students. The science slice is exactly 8 students. This perfectly illustrates why picking a science fan at random is an exact 1 in 5 chance, because 8 over 40 simplifies beautifully down to 1 over 5. But, it's rarely that clean-cut in reality. Let's look at a scenario that is practically guaranteed to trip you up if you aren't visualizing it. I want you to actually pause for a second and consider this apparent paradox. It's a situation where the parts actually add up to more than the whole group. Okay, here's the setup. A group of exactly 21 friends goes out for the day. 9 of them decide to see a film at the cinema, and 15 of them go for lunch. Wait a second, 9 plus 15 is 24. But there are only 21 friends in the whole group. So how on earth is it mathematically possible to have 24 activities distributed among only 21 people? This right here is the whole trick. The crucial point is that by systematically breaking down the numbers, we uncover the hidden overlap. We find the 3 people doing both. Let's walk through the logic step by step. Step 1, just add the total activities. 9 filmgoers plus 15 lunchgoers equals 24 activities happening. Step 2, subtract the actual total number of people. So 24 activities minus 21 actual people means there is an overlap of exactly 3. Those 3 people did both. They saw the film and they grabbed lunch. Now for step 3. Isolate the exact group we want. We take the 9 total filmgoers and subtract the 3 who also got lunch. That leaves us with exactly 6 people who were film only. So if you're asked for the probability, that leaves exactly a 6 in 21 chance of picking someone who only went to the cinema. Venn diagrams are amazing because they force us to see the overlap that our brains normally just miss.
All right, Section 3, Mutually Exclusive Events. Armed with our visual toolbox of trees and Venn diagrams, we are totally ready to master this first major law of probability.
Now, this is where the math becomes beautifully simple, provided you understand the constraints of the real world. By definition, mutually exclusive events are outcomes that simply cannot happen at the exact same time. Think of it like a fork in the road, where you literally, physically cannot take both paths. For example, if a bag contains 12 red sweets and 8 yellow sweets, and you pick exactly one sweet, it cannot be both entirely red and entirely yellow at the same time. Because there is absolutely zero overlap between these outcomes, the math is as simple as addition. You just add the individual probabilities together. Oh, and by the way, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's look at how this brilliantly illustrates the real-world application with a fantastic example from the source data. Imagine a world-class swimmer in a 50-meter race. Based on her past performance data, she has a 0.72 probability of winning the race outright and a 0.25 probability of finishing second. What's the probability she finishes in either first or second place? Well, she physically cannot finish in both first and second place at the same time, right? No way. They are mutually exclusive. So you simply add them up. 0.72 plus 0.25 gives her a massive 0.97 chance of achieving either outcome.
Let's head into our final part, Section 4, the Combined Events Rule. Let's see what happens when a single outcome can belong to two different winning conditions.
So, we just talked about things that can't happen together, but what happens when events do collide? Imagine laying out a standard deck of 52 cards. Let's say you need to calculate the probability of pulling either a black card or a king. Well, okay, you have 26 black cards in the deck, and you have 4 kings in the deck. If you try to just add the 26 black cards to the 4 kings, you accidentally count the king of spades and the king of clubs twice. They are sitting right there in the black card column, and they are sitting right there in the king's row. If we just added 26 and 4, we'd get 30, which is mathematically incorrect because of that double counting trap.
To fix this, we have to use the combined events formula, which mathematically forces us to subtract that overlap. Now, I know the formula might look highly technical on screen. The probability of A union B equals the probability of A plus the probability of B minus the intersection of A and B. But conceptually, it makes perfect sense. We take the 26 black cards, we add the 4 kings, and then we just subtract the 2 black kings that we accidentally counted twice. 26 plus 4 minus 2 gives us exactly 28 unique winning cards, giving us the correct 28 out of 52 chance.
All right, let's test this with one final highly practical challenge before we wrap up today's explainer. Look at this survey of 100 people. 72 people have had a beach holiday, 16 have had a sightseeing holiday, and 12 lucky people actually did both. So what is the exact probability of choosing someone at random who did either a beach holiday or a sightseeing holiday? Let's walk through the solution together. Step 1. We add the total probability of beach and sightseeing. 72 out of 100 plus 16 out of 100 gives us 88 out of 100. But remember, that 88 includes the people who did both, and we just counted them twice. So step 2, we absolutely must subtract the double-counted overlap. That is the 12 out of 100 people who did both. Step 3, we arrive at our final combined probability. 88 minus 12 is 76. By applying our rule and subtracting the 12 overlap tourists, we arrive perfectly at a 76 out of 100 probability. This proves exactly how powerful visualizing that overlap truly is for getting the right answer. As we finish out today's explainer, I really want to leave you with a challenge. How can visualizing the hidden overlaps in your daily decisions change the way you calculate risk? It is time to stop relying on blind guesses. Whether you're dealing with a sequence of events where your total pool is shrinking or simultaneous events with hidden overlaps, start drawing out the probabilities. Once you visualize the tree branches and map the overlapping circles, the complexity fades and the truth of the numbers simply falls into place. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target graded for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
Thanks for joining me, and keep mapping your outcomes.